The second main category of algorithm sets are algorithms which are only used for your last layer. The first main last layer algorithm set that I'd suggest learning is COLL. So we use COLL algorithms for the OLL cases where we already have edges oriented and we need to just orient the remaining corners. COLL algorithms both orient the corners and permute them so that we only have an edge PLL after we do the algorithm. The hardest part of learning COLL is getting used to the recognition. Here's an example of differentiating between two soon cases for COLL. So in this first soon case, we look on top and we have two opposite colors which are diagonal to one another. So the opposite colors are here and here. And then if we look here at this sticker, this color is opposite to this color up here as well. So remember to ignore the edges, and this is just one way of recognizing that we just have a normal soon case. So these two are opposites and these two are opposites, which is the normal soon case, just RU, R'U, RU2, R'. And now our corners are all solved. This case is slightly different, where for example we have the two opposite colors at the back here, so the orange and red are at the back here, and if we look at this sticker, it's orange which matches up with this one up here. So that's what we would do to actually recognize this case, which is a Nicholas algorithm, which goes like this: R, U', L', U, R', U', L. So we see that's oriented the corners of our last layer and permuted them as well, so we only have an edge cycle for PLL. So there are 40 distinct COLL cases that you can learn. COLL is particularly useful for one-handed solving, where it's better to have edge-only PLLs. Personally, I don't use too much COLL during two-handed solving, as in a lot of the cases it's just faster to do the quickest OLL algorithm and then do your PLL. In any case, it is very useful to learn the COLL algorithms as well as corner permutation recognition. One huge last layer algorithm subset is ELLCP. So these are algorithms which both solve your OLL and permute the corners of your last layer. To do these cases, we'll again need to use corner permutation recognition like we did with COLL. So here's just a quick example with the wide soon algorithm. For example, if we have the normal soon case like this, where they're opposite there and opposite there, we can do our normal wide soon algorithm like that, and our corners are permuted. If we have a case where the corner stickers are opposite on the right hand side, and these two are opposite like that, we can do an algorithm L'U2, L'U2, L'F', L'F', which solves the OLL and the corner permutation. And another example is if we have two corners opposite at the back here, and these two corners are matching, so these two are opposite, then we can do an algorithm F, R', F', R, U2, R, U2, R'. So for almost every OLL case, there'll be 6 possibilities for corner permutation. I definitely do not recommend that you go ahead and learn every single case for every single OLL and then try to do that in your solves. Most of the time, doing the fastest OLL algorithm and then doing PLL is probably faster than doing an ELLCP algorithm and then doing an edge PLL. However, where there are a few easy algorithms for a single OLL case, I would recommend going ahead and learning those. So it can just be 2 or 3 different algorithms for one OLL case. So learn those and learn what they do to affect corner permutation. The last algorithm set is the famous ZBLL algorithm set. So these algorithms are used when you have your edges oriented in your last layer, and they solve the entire last layer in just one step. So this requires you to not only recognize the corner permutation, but also the edge permutation around the cube. So recognition for ZBLL cases is very tricky. There are over 400 algorithms for ZBLL, and only a few people know and actually use all of them in their solves. By no means do I suggest actually learning ZBLL. If you are interested, there are resources available which have all the ZBLL algorithms, but for the most part, I'm just trying to give you an exposure and understanding of the algorithm sets that are out there. If you are interested in learning some ZBLL, I'd recommend that you do it one OLL case at a time. A relatively easy case to start on are the T ZBLLs. Make no mistake though, when you do recognize and execute them quickly, ZBLLs can be very, very fast. Here's just a few examples. So those are the main last layer algorithm sets. To find actual algorithms and cases, check out the algorithms section on CubeSkills, as well as Google and the World Wide Web.